So the people that have already come and joined us today, it'd be great if you guys could turn on your cameras just so we could see your awesome faces. Totally okay if you don't feel comfortable doing so though. But yeah, we'd love to see your faces. Yeah, Jason. All right, it is officially 5 up, so feel free to start whenever.
Okay, thanks everyone for coming today. I'm really excited to be here, so I'm just going to share my screen with slides. Let's see. Oh, sorry. Okay, I realized I have to share the screen first and then present. Okay, got it. Okay, so I'm really excited to be here. My name is Annelise, and I am from Los Angeles, California, where I am right now. I'm really excited that you're doing projects on social good and building bridges to environmental good and just all this kind of really, really powerful work in technology because I have been involved in a lot of programs that are supposed to really amplify voices that haven't been heard in STEM. So like women, minorities, girls, and other people of color and people who are socioeconomically disadvantaged. Uh, and this is really interesting to me because in artificial intelligence and extended reality, which is an umbrella term that I will discuss later, a lot of people are excluded in the way that artificial intelligence has been set up historically. So there are a lot of implications that this has in order to apply ethical artificial intelligence into projects. It's really important to understand these complex ways that that tech actually involves us and necessitates change from all of us. So to start out, artificial intelligence is probably the most well-known term. There have been lots of pioneers shaping this field and significant events, but artificial intelligence generally is a branch of computer science dealing with the simulation of intelligence, intelligent behavior in computers and machines. This also ties in with machine learning. And you'll see later how there are actually a lot of fields beneath the term artificial intelligence that people actually don't think of, which is why I used the term extended reality earlier, because you will see this is the capability of machines that humans have created in sort of our image, like, yeah, basically kind of in our image. So here's a quote from a pretty famous woman in tech. She's the CEO of IBM. And I liked this quote because it really illustrates the nuances and complexities. She kind of does a little play on words here, saying some people call artificial intelligence this artificial intelligence, but the reality is that this technology will enhance us. So it's intended to actually amplify and extend human capabilities. And this is why it's so amazing for our future, because it can actually augment our intelligence, which means build upon and enhance, essentially. So artificial intelligence is already more complex than one realm. And historically, not many people know about its different divisions and realms. So I'll just briefly discuss them here because they're pretty important to know. So augmented reality adds digital elements to a live view, often by using a camera on a smartphone. And I'll show you lots of examples later. There are lots of fun applications and important applications, and some have been actually historically oppressive and biased. So this is where the implications come in. But examples that you might know of augmented reality include Snapchat lenses and the game Pokemon Go. That was kind of popular a while ago with the kids, but yeah, virtual reality you might have enjoyed. I actually have not used it myself, but I know you can get different lenses like Google Cardboard or Oculus Rift is a more fancy device that you can use, and it transports users into a number of real world and imagined environments, such as the middle of a dungeon, even though you're in your own home. So that's another branch, and it's virtual reality or augmented reality. They already have different nuances. And I'll show you examples in following slides, but mixed reality then just combines AR and VR. So that's a good term to use. Thinking of Microsoft's HoloLens, if you've heard of this, it's one of the most notable early mixed reality apparatuses. And then extended reality is what I realized I need to use when I'm discussing what I really research, because it's just the umbrella term that covers all of the various technologies that enhance our senses, whether they're providing additional information about the actual world or creating something totally unreal. This includes virtual reality, augmented reality, and mixed reality. So it's encompassing, it's all encompassing. And this is why Ginny Rometty's quote seems pretty fitting. It makes me think of augmented intelligence and less so artificial reality, but maybe that could be something that someone could make exciting, could develop into something that can augment our intelligence again. So here what I really wanted to compare and show you how there are positives and negatives of AI, and some of these are a little bit more ambiguous. They can be either, as you can see with accelerated hacking. Of course, you're at a hackathon and what you're doing is coding, creating projects, doing amazing hacking work, and yeah, just being creative. But hacking can also be used negatively, such as to steal data, private credit card information, or even social security numbers. So the internet can be amazing or dangerous. Technology, of course, really anything has an extreme positive side and an extreme negative side. So most of the history of AI has actually been familiar to us, but through biased data, we see Siri, maybe you have on your phone, Siri, Alexa, or Cortana on your Microsoft device, Alexa on your Google products, but the bias in AI is actually historically been because algorithms have been built by humans who have built-in biases that they either have intentionally or inadvertently introduced into their algorithms. So coders who I do also discuss later how like coders are actually, there are many statistics showing the lack of diversity in AI especially, and extended reality encompassing all of these, but especially artificial intelligence. So it's important to get diverse perspectives and to actually compile data so that these coders can build algorithms that serve diverse populations like us, and not just the top wealthiest people or people who have been historically privileged. So if AI algorithms are built with a bias or the data in the training sets they are given to, they learn from this, and this can be biased, and it will, of course, if the input is biased, then the output is guaranteed to be biased when we are working with extended reality technology and issues. So it leads to many unintended consequences, but and these don't necessarily match up. So any of these household, you might call them, AI examples like Apple iPhone Face ID or job automation, although I guess that's at your job, but semi-self-driving cars, because there are no fully self-driving cars yet, spam filters, even Snapchat, Instagram filters, and these are all actually great technologies. They can be used for good, and then they can be used for bad. And then on the right-hand side, you see some historical sort of like gray areas where we see a lot of the bias play out, and actually the product of some of the same algorithms that might have developed the Face ID might be used for predictive policing. So giving data to administrative sources who use that in a way that is biased because of the algorithms that have been put in place. And AI companies need to be trained to develop their products responsibly. And people who are using it can really help with this, because the more voices are able to speak out against what's going on that's wrong with all of the AI that we see in like global regulations. There are a few controversies. If our world is getting smaller or more connected with technology, we need to allow like safe and effective global initiations and interactions. So these are really like relying on artificial intelligence. We don't know how safe they will be unless someone's regulating them. And products like TikTok, for example, has had a bit of a controversy in the United States because apparently maybe it was going to be sold to someone else, or it's owned by an Asian company, and the leaders in power here were not okay with that, it seems. So we definitely had experienced these areas where technology's been kind of like a focal point of concern. And this has to do with just safety of the citizens in the country. And leaders can't be really like dictating how using it as a weapon against us. And so we have seen like Europe has adopted a robust regulatory system to ensure consent and transparency, while the US and China particularly allow the companies to apply AI much more liberally right now. So we will see how that plays out. Again, AI is really new. It's a really new facet of technology and learning, and it's so fascinating to see it play out, but we also have job loss coming into the equation because of automation. Now, this isn't necessarily a negative thing because some jobs are maybe dangerous in themselves or time consuming, and they don't actually mean too much, but for some people, they are the only jobs available, and they can't just learn how to code without the resources. So this is why the more of us are able to really learn and empower ourselves and then empower others to learn this literacy is really great. So this also, you might have seen shift in experience. Now this relates to the human experience as automation happens and AI takes over menial tasks and allows humans to reduce the time that they spend possibly working or that they need to spend at a certain job. It seems like maybe a utopia at first glance. However, most utopian endings aren't all so great. So in order to feel like your life has a purpose, if your job was automated away, you might need to find something to channel that into. And not everyone, again, has the resources to do this. So it might be easier for some communities than others, and the economic benefits might not be worth it. So this is something we really have to consider. And of course, artificial intelligence increases the speed of what can be accomplished. And so for accelerated hacking, in many cases, it allows humans to maybe fish for data or violate and push viruses out and take advantage of AI systems because of the way that AI systems view the world and how they're so integrated into, or they're becoming quite integrated into many communities, even without their knowledge. So this is all important to remember, and that was kind of a lot, but just points to meditate on as we go through. So what we're really interested in here is sustainable artificial intelligence and extended reality, because if we take what we know from past experiences, for example, some Snapchat filters in I think 2016 were basically allocated against because they didn't recognize someone as someone's face as an actual face because they were Black and their skin was too dark, apparently, to be recognized correctly by the algorithm. And this is a huge problem because it kind of dehumanizes a certain group of people just because of the way they look. And if this is because of the data that's been entered, now Snapchat has been sort of known to be not a very diverse company, at least at that time. It's definitely changing now, but this is a problem at the big tech companies, as primarily white and some Asian leaders have been dominating the field and just not allowing, kind of excluding other voices. So it's not a problem that they're doing so well and succeeding, but the problem is they're not bringing in others and including their perspectives so that this technology can be developed for all of a diverse population who may not look the same, may not talk the same, and needs different devices to go through and enjoy technology. So we look at reactive machines as one point of successful sustainability, excuse me, because the most basic types of AI systems are purely reactive, and they have neither the ability to form memories nor to use past experiences to inform current decisions. So Deep Blue is IBM, the company that Gloria, or Ginny, the CEO of IBM, is obviously working for, but they developed a super playing chess computer which beat the international grandmaster Garry Kasparov in the late 1990s. So this was an early bit of history, and AI was very young then. This is the perfect example of a reactive machine. It can identify the pieces on a chessboard and know how each one moves, and make predictions about what each move might be next for its opponent. It can also choose the most optimal moves for many possibilities, but it doesn't have any concept of past nor any memory of what's happened before. And so therefore it can't project anything into a future as we can see. So memory and future are very interconnected, which is interesting because history, as some people famously say, repeats itself, and it doesn't have to, though. Maybe it repeats in different ways, and we can see this in different ways. But for AI, the goal is to develop it so that it augments our intelligence. It actually extends it and doesn't necessarily reach back into painful troves of data, but goes forth with diverse and inclusive memory and perspective. So for the second point, limited memory has to do with machines that can look into the past. So self-driving cars, which are being developed all the time, there's a certain scale of how self-driving they are, because there's still a lot of user input involved in most commercial self-driving cars, but they do some of this already. So for example, they observe other cars' speed and direction, and that can't be done in just one moment, but rather it has to take in patterns and identify specific objects, monitoring them over time. So this can add to a sort of like repertoire of movements and memory that extends to make up for human shortcomings in the self-driving car by letting the machines build their own representative memory in a sense. So the third point, theory of mind, is called theory because it's not exactly, we haven't reached it yet, but it's the divide between the machines we have and the machines we build in the future. So this is like the point where you can come in and you can develop something that's totally new. And it's better to be more specific to discuss the types of representation that these machines need to form and what they need to be about. So this is why having more people producing and thinking and being included in the development of these artificial and augmented minds will be definitely beneficial, and it'll help to understand the people, creatures, and objects in the world that have thoughts and emotions affecting their behavior. This is crucial to how humans formed societies, actually, the theory of mind, at a root level. So this allows us to have social interactions, and if we're able to use AI as a system to indeed maybe like walk among us, like robots being able to actually process things even at a much higher, more complex level, they'll have to be able to understand that each of us has thoughts and feelings and expectations of how we are to be treated. This will have to, this is very very nuanced because people have to be so careful about adjusting behavior accordingly and translating this into technology. So we definitely can't have oppressive biases infiltrating here. And the last section for sustainable AI, kind of like timeline pathway, would be self-awareness. Humans are quite usually fully self-aware, and the final step in AI development at a theoretical level is to build systems that can form representations about themselves. So to be actually aware of their, conscious of their existence, sort of. This is an extension of the theory of mind, but it's also called self-awareness because, for example, saying I want that item is a very different statement from I know I want that item. And this is what differentiates humans from machines most basically most tangibly, most not abstractly, but really like implicitly here. We assume things, and we're probably far though from creating machines that are self-aware, but we should focus on our efforts towards understanding memory, learning, and the ability to base decisions on past experiences so that we can carefully go about developing, because this is really the epitome of AI, as some researchers have found, and this really affects what we want to see in front of us when it comes to mixed reality and extended reality. So the first section that I wanted to cover is computer vision, because this is a very big role. It has a very big role in our daily, day-to-day lives and how we use our own technology. And so maybe it can inspire different changes for future of AI. And I was going to just break down each section a little closer. So we have some examples. So some fun graphics are coming soon. But computer vision is actually a direct opposite of computer graphics, which produce image models from 3D models. So this is producing 3D models from image models. So basically 3D from 2D. This is so that the computer can create a 3D space from image data. So we see this in self-driving vehicles, which are being developed. Also, we know that there are 5 levels of automation based on 5 autonomous driving factors. And this is where there are scales of, for example, like road monitoring and steering, acceleration, deceleration, monitoring surroundings, and fallback for self-driving failures. These are all aspects of self-driving cars, and there's no level 5 self-driving car because that would be full automation and no real user tinkering or input. So this is common tech that computer vision makes possible. It uses camera, as in Google Lens or scanning paperwork. They all use cameras, and this is famously claimed to be the only sensor technology needed for self-driving cars, but we need the algorithms to be able to fully comprehend the images that they receive. So camera images capture everything needed for a car to drive, but we're still developing new ways for computers to process the visual data and translate it into 3D actionable data. For example, Tesla cars have 8 external facing cameras to help them understand the world around them. And of course, this sounds like very complicated. Sometimes if you think of how you understand the world around you, like for me, I don't know how that exactly even works, but for computers, we can replicate vision using the amazing light and dark shadow color recognition that cameras have. They can also recognize depth, which is important, and that has to do with the 2D to 3D transferring of data and information that the computer can process. So just quickly, other technologies that are part of self-driving cars and work with the computer vision are radar and LiDAR, which are sensors that spin on top of self-driving cars. I don't know if you can see in the image, but yeah, sorry, you can't see in this image, but the car actually sort of sees the environment from this angle, and of course it doesn't have a picture of itself. But yeah, most self-driving cars have a little spinning radar. And then they usually have other sensors, and the computer power is essential. They use different graphical processing units, or GPUs, to do their calculations, as does this Google phone here. The camera can identify these 2-dimensional environmental inputs, or actually 3-dimensional environmental inputs, through the 2-dimensional screen, and identify what this painting is. So that's an example sort of the reverse of computer vision, but it also uses the same dynamic, so it's translatable in multiple ways. And then also Apple Face ID uses facial recognition, and scanning paperwork can extract data from barcodes and QR codes. So augmented reality, a little deeper dive here. We see filters on the right, possibly Snapchat filters, but it's just to represent how you can have something register your face And this would be the technology of augmented reality placing a virtual or juxtaposed image into your view of reality. So this video game on the left seems to be someone actually skiing or possibly just wearing this lens that makes it look like they're skiing, but I believe it's actually skiing down a slope, and they see these blue hurdles that they have to follow in order to score points. Oh, and augmented, sorry I didn't define it earlier, but it actually means having been made greater in size or value, and it can also denote or contain an interval which is just greater than the preceding interval. So these are interesting technologies that arise from this. So here, augmented reality uses various technologies rendering optical projection systems, monitors, handheld devices, and display systems that could be worn on the human body, such as a harness or helmet for a VR lens. Augmented reality is essentially a view of the real physical world in which users find elements that enhance their environment due to computer-generated input. So they might see a certain image in their own environment through the lens, and it's not actually there. They couldn't touch it, but they feel as if it is because it looks three-dimensional. And designers can create inputs that range from sound actually to video, to graphics, to GPS overlays, and more in the digital content that responds in real time. So it changes the user's environment and also responds to changes in the user's environment. And for the changes in the user's environment, it's really just for the user. This doesn't translate to people who are not using the technology because you have to be peering through a lens or goggles or something of the sort. And there are three basic characteristics of augmented reality, and they have to do with all of them overlay of real and digital world, real-time interaction, and registration and alignment in 3D have to do with a sort of translation that the computer processing does. So for image processing, this is an area to dive deeper into computer science that Snapchat filters, for example, use. It's also used by predictive policing cameras that can that often go against certain communities' will. They aren't informed of the use of these images to actually recognize things. But image processing uses face detection, facial landmarks, and an active shape model. And this is really powerful technology, but that's why it has to be developed with integrity and for use and not oppression. So you can read about how Snapchat filters work here. Just a little bit. They use image processing primarily, and it's the transformation of an image by performing the computer mathematical operations that take into account each individual pixel, on the provided picture. So face detection actually faces some challenges, including detecting tiny partial and non-frontal faces. Now it also has in historically speaking ways, kind of excluded certain populations from the data set because, for example, in that algorithm that couldn't identify a Black person's face, it's pretty problematic if the issue is not necessarily someone meddling with technology or someone deliberately trying to fool the technology, but someone just trying to use it. So this is where the data is biased and the data needs to be readapted and evolved to actually include everyone. Another example of image processing has been more translating what's in an image. So there was a Google in, I believe, 2014, there was a Google controversy where Google would label images of, again, people with darker skin as gorillas, and this is really problematic And this was a way that the computer's algorithms that Google would send would be biased. So this can be either using face detection or facial landmarks, which are, it's the analysis phase, and it detects coordinates on each member of the facial feature. As in the last slide, if you, I should have moved that image to this slide, but if you saw the man looking at the camera, his face was covered in sort of like pyramidal yellow lines and dots, and this is how the image gets processed. So the face has been detected, and Snapchat, for example, can use image processing to apply features onto this full face. However, they can choose to go one step further, and if they want to find your facial features, this is done with the aid of the active shape model. The active shape model is a facial model that's been trained by the manual marking of borders of facial features on hundreds and thousands of images, but sometimes not diverse enough images. So this is, again, going back to the data, but it's created in the image that's provided, and this is an average face image. So taking a lot of data points, it graphs an average face, what they think is going to work for the greatest population to be able to use this technology successfully. So the average face, of course, does not fit exactly into or overlay on top of the user's face because we all have different faces, but the pixels around the average face will sort of be examined to look for differences in shading, and the training of the algorithm that the algorithm actually goes through when it's being developed accounts for this ability to be able to translate for different faces. So this is a machine learning process as well, going back to how most of these are pretty interconnected. The technologies are used together to develop such amazing products that we see as Snapchat face filters, and hopefully there will be no more real issues with people not being represented in the data, but we can just try our best to understand how these work and how people develop these technologies, and then try to, maybe if you're able, change it yourself, or to allow someone to see and change. And yes, so another section is natural language processing. This is a really interesting section because NLP, as it is called for short, has been around for more than 50 years. It's a little bit more developed and trusted than other ways because it uses, I guess, less senses than like visual can be violating in certain ways, and language is mostly, or I'd say more voluntary in the context of artificial intelligence use of it. So this study has grown out of the field of linguistics with the rise of computers. So actually, as computers were being developed, natural language processing was as well. So it's broadly the automatic manipulation of natural language, like speech and text, that humans also communicate with by software. So software will try to understand what humans are saying, and vice versa. Except the human doesn't do the translating work usually, unless you're a developer or a coder, and the computer will process your speech and give feedback in your speech. So NLP is collective, and it refers to the automatic computational language, so automatic computational processing of human languages. And this will include the algorithms that take the input and that produce natural looking text as outputs. So that's just another way of phrasing what I was discussing, just about the machine doing the work, basically. And then natural language processing has different layers. So speech and text are two different types of input, and they interact, or they foster interactions between computers and human languages. NLP gives machines the ability to read and understand the languages that humans speak. The NLP system would enable the NL user interfaces and the acquisition of knowledge to come directly from and go directly to the human written sources or spoken sources. So audio input uses phonetic or phonological analysis to interpret that section, and then from text, there's OCR or tokenization, which is optical character recognition or optical character reader. And as we know, when we type, there are characters we use to represent sounds and phrases and words. And this is what OCR or tokenization does to translate it to computer binary code, basically, or whatever program you're using, whatever it runs. This is the electronic or mechanical conversion of images of typed, handwritten, or printed text into machine-encoded text, such as binary code, whether from a scanned document, a photo of a document, a scene photo, or from subtitle text, for example, superimposed over an image or video. Morphological analysis is the next stage, and this is for information retrieval. So I'll just go through these quickly because they can be more complex, but they actually are kind of less complex than the term sound. So morphological analysis is just for information retrieval, excuse me. So it uses a query for phones, can match the phones and the sounds, and uses language modeling. For example, if we've seen the word scrutinized, we can predict scrutinized, and the machine can also use root words to deconstruct these human words into more processable phrases and uses those to be able to predict outcomes and inputs. And then syntactic analysis is also known as parsing or syntax analysis. And this is the process of analyzing a string of symbols. So maybe there are some that are still characters, some of the input is still in character version, and then it's being translated into the computer's program, and the device will read it and start to translate it. This always reminds me of DNA somehow, because it's kind of like encoded different levels of information being stored and transported. So just for if anyone's curious, the term parsing comes from Latin pars, oratonus, which means part of speech. And semantic interpretation is used as a common method of processing and extracting meaning from the natural language. So once the natural language is already being processed and translated in the machine can start to interpret what that means for what it implies and what it can do to interact and facilitate further connections and respond basically properly. The last section, discourse processing, is a suite of natural language processing that is tasked to uncover linguistic structures from texts at several levels. So basically, this can support text mining applications or asynchronous conversation. It kind of can store discourse. It actually can analyze discourse, and that's how the higher level is applied there, because it can kind of remember and predict, and that's all exciting capability. So here are just some examples quickly. I know I have used Siri before, and I have an Apple iPhone, so Siri is on there, and I can ask if I'm listening to a song, for example, and I don't know the name of it. I can just ask Siri, what is the song? And Siri will register the incoming sound, and then can actually like search for me the song and will bring up information about it. So that's kind of a dialogue I'm having with the algorithm there, which is pretty interesting. Other ways that this can be applied are in machine translation. So actually using Google Translate is exercising these natural language processing algorithms. You can also use the speech or the text in translation apps or Google Translate, for example. And yeah, it's very, very handy. Question answering is more just the broader way of describing these tasks, but there can also be other questions, like, for example, what is the weather today in Chicago? Or or like asking to do a task. So you can ask a machine to maybe search the web for rock concerts nearby or something. And this would be generating answers from a natural language sort of like text database or collection that connects with external sources. And it all makes the algorithms smarter in a sense. And hopefully can make you smarter too as you learn the answers to your questions. So basically, natural language processing can also be a helpful assistant in creating conversation and finding answers, and all of this results in augmented capabilities for humans. Okay, so in order to improve AI, there needs to be some shifts. So I definitely trust the UN Sustainable Development Goals are one great resource that kind of inspires what I know about environmental justice and even technological advancement, because there are ways that we need to make sure technology won't deplete our human experience, and that we can also enhance, so amplify our own voices through technology. In this chart on the top right, there are a few targets of the UN Sustainable Development Goals that are impacted by AI, and some are enabled by AI, and others are actually inhibited by AI. So there are more that are enabled by AI, but this is if we apply it in smart ways. And below it, you can see different applications that you might be interested in using, whether on a big scale, a large scale, or a small scale, with possibly like a whole internet at your hands, or visualizing data or text or images, and analyzing, doing robotics. So these are just a few examples of how we think of AI, but how can we actually improve it so that it can improve us, essentially? Because if we are going to be able to move in a world where people are accepted and able to use AI so it's accessible, we're going to have to make it sustainable. And another quick framework for this is to develop, de-identify, decipher, and de-bias. And this has to do with not demonizing nor romanticizing AI, but rather using it to close the digital divide and unite people and really connect and create bigger and better things. So AI has to be more inclusive, and this will help involve and advance social inclusion. Now, the World Economic Forum actually coined a phrase, the fourth industrial revolution, that describes what sweeping changes technology is set to make in our world at the pace that we're already going at, where a lot of people have been called out for using historically biased training and not incorporating enough diverse data in their algorithms. So the fourth industrial revolution will irrevocably alter the fundamental ability to trade time and skill for money. This is just a more logical way of describing how automation is happening, and we need to know exactly what AI can do so we can be part of it. And this needs to apply to all people, not just wealthy and privileged individuals or people who look a certain way. So when a survey was conducted about what consumers think about AI across the globe, there were different technologies that are in place today that are actually projected, that are likely in the future, and then projected as unlikely in the future. And if you see the different colors, the green is in today how we use AI, for example, to solve problems and replicate human interaction. Importantly, not duplicate or extend human interaction, because human interaction is essentially at a higher level than machine and robot interaction. This goes back to one of the first experiments done with multiple machines, and I think AL, one computer that was set to try to replicate a human conversation, and humans would go in and see if they could tell if it was a real human or not. And ultimately, it did show that while a computer can trick humans, as in interactions seem to be human enough, it's not fully 100% accurate or reliable. And yeah, so a lot of what AI can do is very neutral. It's not negative. It doesn't have to be positive, and it shouldn't be hopefully negative. So we have a lot to build from, and that's exciting. Now, interestingly, some increasing capabilities, like I was discussing how self-driving cars aren't actually fully automated yet. Surveillance on people isn't fully AI responsive or responsible right now, and video games aren't fully yet, but they're increasingly becoming an issue in our society. And so people actually realize that. Not many people know that AI runs surveillance on them, however, as seen by the 18%. So then we see this purple section where people projected that AI might take over the world or control your mind, even feel emotion. And these are all things that AI is not projected to do. So this is not going to likely be a goal. It's theoretically been challenged, discussed, and debated, but this isn't the point of what we're developing. And it's reassuring to know that robots won't take over the world. So as we near the end, I wanted to just discuss a few quick points about how AI is going into the future. So maybe I hope you can get involved. I hope I can also get involved and create more access for people to go into AI and not be affected negatively by AI, rather to be affected positively. So 45% of 2,000 work activities examined by McKinsey and Company could be automated in our world using technology that's already been illustrated. We already have certain technologies related to artificial intelligence, but these affect women more likely than men. And there are also racial breakdowns and socioeconomic breakdowns, but most of my research has focused on gender divide. And so men will face actually nearly 4 million job losses, and then some gains because majority men are in artificial intelligence leadership positions and developing this technology. So they're going to gain those jobs. They will lose approximately 3 jobs for every job gained, whereas women are going to face 3 million job losses, but then only 0.55 million gains, which is more than 5 jobs lost for every job gained. And so we have to think about, in the future of AI, how we can create accessible technology that begins with representing those who might be marginalized or underrepresented, and technology for social benefit. Actually, I found Google has a whole sort of resource of social and environmental justice examples of how AI can be developed. And I can send that link if anyone's interested, but I probably don't have time to like show it to you, but I have the link. And Jennifer, should I share the link, or do you think people would be interested in it?
Yeah, you could just drop it in the chat.
Okay, sure. And so, oh, actually, I think if you can see this, it might have clicked on it, but I I can share after. So basically, AI can be applied to some of the world's biggest challenges, like coding can, and this is what you're doing with your projects too in the hackathon. You're trying to solve real world problems, and this is amazing because hackathons are also relatively new, and there are many different ways that machine learning can impact like all of these different projects. They're very, very applicable to life right now. And yeah, so that was just briefly examples that Google has been putting their resources into. And some of this is able to actually include and amplify diverse perspectives. This is what people in power need to do. It's not necessarily your responsibility yet. Hopefully you'll be able to be the new face of artificial intelligence. But so many people are excluded from AI right now as it is, like women and people of color and LGBTQ community people who are maybe transgender, bi, etc. There's not much representation besides sort of one narrative of like a wonder kid in his basement who finds technology and coding accidentally and develops something amazing. It's all sort of not making inclusion at the heart of innovation. And this is just because of a few ways that precedents for measuring and ensuring algorithm fairness have not been put in place because it's such a young existing field and there's a lot of work to do. Some certain legal standards put in place that could make an impact as we think about elections coming up would be the Equal Credit Opportunity Act, the Civil Rights Act, the Fair Housing Act, and guidance from Equal Employment Opportunity Commission. They can help mitigate many of the discriminatory challenges posed by AI. And there are steps that companies and individuals can take to actually include more voices and generate clear, good faith justifications for using the algorithms and models that they actually deploy into the technology that we use. AI has so much potential to be really beneficial and to actually guide and create even more fairness in this world. But we need to make sure that voices are amplified who have been excluded from this industry for too long. So here's one quote that I found inspiring by Kimberly Bryant, who is an electrical engineer and founder of Black Girls Code. To close us off, you can absolutely be what you can't see. That's what innovators and disruptors do. And if you are maybe a person of color, a woman, or an older person, younger person, it doesn't matter whether what your sexuality or race is. Definitely just know that you have something to share and your story deserves to be told in augmented reality, extended reality, and beyond. So thank you so much for listening today. Sorry I went a little bit over, but thank you, Jennifer, for being so helpful as well.
Of course, thank you so much for giving your workshop today. Audience members, could we give maybe a virtual round of applause?
Thank you. And then you can feel free to email me if you have any questions too. And there's my LinkedIn in case I'd love to connect with you because I'm always inspired by other people's AI projects and coding and anything.
All right, awesome. Yeah, this was a really awesome and informative talk. I definitely learned a lot more about AI than I did previously, so thank you.
Thank you. I'm so glad.
All right, and with that, I'll see you guys later. I'm gonna end the call right here. Thank you again, Annelise.
Thank you, everyone. And thank you, Jennifer. And good luck with your projects and the rest of the hackathon, too.
All right, bye.